carrier, one is majority, one is minority. Okay, so this minority carrier, due to the minority carrier, we are getting the leakage current. Now, if I make such that the device will operate only due to one type of charge carrier, that is only electron or only hole, then I can say the leakage current problem will erase. Okay, so that type of device are called as unipolar device, and such type of device, one of the device is called as field effect transistor. Okay, so the full form of FET is F for field, okay, F for field, E for effect, T for transistor. Field effect transistor. So in detail we will discuss. First let us discuss the similarity and dissimilarity regarding BJT and FET. So BJT, the main purpose of BJT is amplification. So they can use as a amplifier. So as this is also one type of transistor, the FET also can be used as amplifier. Next one is switching device, like diode can be used as a switch, transistor also can be used as a switch. If you remember the characteristic of transistor, like this we are getting. Okay, so these are saturation region and these are cutoff region. So cutoff means we are not getting any current, saturation means we are getting this current, maximum current. If I try to operate my transistor in on condition, I'll operate the transistor in saturation region. If I want to operate the transistor in off condition, I can operate the transistor in off cutoff region. That means if I switch the transistor between saturation and cutoff region, then I can use 1 and 0 such that it will toggle between this 0 and 1, or I can operate between 0 and 1 on condition, off condition. Okay, so transistor can be used as a switch like in diode. So here also FET can be used as a switch because this is also one type of transistor. Next one is impedance matching. So what is impedance matching? I'll explain in feedback circuit. So for the timing, you just remember this impedance matching can be done by these transistors. Okay, so amplifier, switch you know, and switch I'll explain later on. So you just remember the transistor can be used also as a impedance matching circuit. Now these are the differences. So one by one we'll discuss. So first is BJT. So BJT is a current controlled device. So if this is BJT and this is my input, this is my output. So we are getting IC equals to beta IB plus ICEO. So this is my output, this is my input. So output is controlled by input or not? If I'll change IB, IC will change or not?
Yes.
So that's why the input current is control the output current, or I can say output current is controlled by input current. So that's why the BJT are called as current controlled device. Is it clear? These are short questions you frequently will get in the MCQ or quiz, and same Viva as well as in any other exams. So BJT are current control device because output current is controlled by input current. but FET are voltage control device. So if you see this figure, this ID is my output. Why I have written ID, I'll explain a little bit later. ID means drain current. So this is my output, and input is between these two terminal, which is called as gate to source voltage, right? So output current is controlled by input voltage, not input current. Okay, so output current is controlled by input current, input voltage. That's why these are called as voltage controlled device. Also, this voltage is due to the change in electric field, or we can say the voltage and field are interrelated. So that's why the device is called as field effect transistor. Field means electric field. What is the effect of electric field or potential on output current? That's why these are called as field effect transistor. Okay. Is it clear? अरे समझ में आया कि नहीं?
Yes, sir.
कि नहीं तुम बोलो. So this point we have understood FET are voltage control device, BJT are current controlled device. Now, little bit later we'll see the BJT are bipolar device, but FET are unipolar device. Let us go to the structure, then we'll discuss those things. So basically, the FET are two type. One is junction field effect transistor, another one is metal oxide semiconductor field effect transistor. So junction field effect transistor is called as JFET, and metal oxide semiconductor, M from metal, O for oxide, S for semiconductor, will combine to form this MOS, then field effect transistor. Again, this MOSFET is classified in two categories. One is depletion type MOSFET, which is known as D MOSFET, and another one is enhancement type MOSFET, which is called as E MOSFET. Again, the JFET are like NPN transistor and PNP transistor. Here also, JFET are classified in two categories. One is N-channel JFET, other one is P-channel JFET. Similarly, enhancement type MOSFET also N-channel enhancement type MOSFET, P-channel enhancement type MOSFET. Similarly, depletion MOSFET is N-type or N-channel depletion type MOSFET, P-channel depletion type MOSFET. So basically, like BJT, JFET are also classified into N-channel JFET, P-channel JFET, and MOSFET depletion type again N-channel, P-channel, enhancement also N-channel, P-channel. Now, if you consider the transistor, this is my transistor symbol, and how many terminals are there? 3. So this is my PNP transistor. So P, N, P, which are called as emitter, base, and collector. Now in FET, these names are not given. This collector, base, and emitter are not there. We'll replace these names with some other name. So emitter means, why we have given emitter as name? Because it will emit the charge carriers. So instead of emitter, here we'll give the name as source, denoted as capital S. This is the source. Okay. Similarly, collector is collecting the charge carriers. So here we will not give collector as name. This name is drain. That is represented as capital D. So this is your drain. Now what is the work of base? It is controlling the current from emitter to collector. So instead of gate, base will take as name as gate. PE represented as capital G. So instead of emitter, collector, base, the names are changed as drain, gate, and source. Okay. Like NPN transistor is more widely used due to the mobility of electron is higher than mobility of hole, here also n channel JFET are more used compared to p channel JFET. Any doubt up to this?
No, sir.
Now this is the symbol, n channel JFET and p channel JFET. So instead of this inclined line, these are the horizontal lines which you need to put. So this is your drain, this is your source, and this is your gate. Now arrow mark is given at gate, but in case of transistor, emitter is arrow mark, but here gate is arrow mark, and arrow mark is incoming means n channel and outgoing means p channel. But in case of NPN and PNP transistor, incoming means PNP, outgoing means NPN. So this is only change, means reverse direction is mentioned, and here these lines are not inclined, these are the horizontal lines. Okay, so you practice these symbols little bit, then you understand. Now we'll see the structure. You see, I'll give the structure. I'll draw the structure here so that it will be easy. So what is the structure? First you will take one type of material. Okay, let us take as n-type material. Now once you take n-type material, two sides of it will dope with p-type material like this. This is my p-type material, this is my p-type material. The material which are p-type are called as gate. So two gate, instead of one gate is there, I have shown. So these are actually sorted. So these two gate are sorted here. So it will work as a single gate, because whatever voltage I'll give, I'll connect the same thing to two gate. Now this is one terminal, this is other terminal. So this is your drain as D, and this is your source as S, and this is your gate as G, right? So this is the structure. First you take one semiconductor, then two side opposite type of metal will be doped, which are gate. Vertically two are drain and source. You can also take as horizontally, no problem, but logic will be remain same. See here, in this figure, the entire thing is n-type material. Okay, and this is gate, which are p-type material, then source and drain. Clear?
Yes, sir.
Now we will go to little bit deeper. Now I want to operate the transistor. This is my JFET and I want to operate it. Operate means I'll use this transistor, and I know I need to control my output current. So output current, because source means it will emit the charge carrier and drain means it will collect the charge carriers, and here I'll control the charge through the gate to source terminal. That means this is the voltage VGS through which I'll control the carrier transform from source to drain. This is my source, and from here to here the electrons will move, right? Like BJT, what we are taking? This is my emitter, base, collector. So emitter will emit the charge carrier through base and it will collect here. So this is my output, this is my input. So basically the carrier will transform from input side to output side or emitter to collector, and this base is controlling that. So here also from source to drain the carriers will move, and the controlling parameter is gate to source voltage. So how it is controlling? See, now are you finding any PN junction in this structure? Do you find any PN junction here?
Yes, sir.
How many PN junction you are finding?
Two.
So this is left side is p-type material, entire thing is n-type material. So here one junction and here one junction. Okay. Now if I connect negative voltage to the gate, and I'll connect positive voltage to the drain through source, then tell me this junction is forward biased or reverse biased? Or even if I not connect this VDS, also you can see P is connected to negative potential. This is negative. Now N is connected to 0 because it is open circuited. So if I take PN junction diode like this, P, this is N, P is connected to negative voltage, this is connected to 0 volt. Is it like the structure or not?
Yes, sir.
This junction is reverse biased or forward biased?
So reverse.
Reverse bias. So reverse bias means some depletion region will be there. So let us show that depletion region like this. Okay. Now I'll increase the positive voltage here. 1 volt, 2 volt, 3 volt, like that. So electrons are available in the channel. Channel, why I am calling a channel? Because channel means it is the mode of transfer. That means from here to here the electrons are moving. So the path in which the electrons are moving are called channel, right? So this channel is what type of material? N type or P type?
N type.
N type. So that's why this is called as N channel JFET. Okay. Now I'll connect positive voltage here. So positive voltage will attract more and more electrons from source to drain. So electrons are moving in this direction means current will be opposite to that. So this is your drain current. Now if I increase this VGS, so the junction will be more reverse biased or less reverse biased? Suppose initially I have connected minus 2 volt, now I'll connect minus 4 volt. Minus 2 volt, 1 volt, minus 4 volt, let us take same 1 volt. So this junction is more reverse biased or less reverse biased?
So more.
More means the depletion region will increase?
Yes, sir.
The depletion region will increase means this is the region. Now check it. Initially my channel width is from here to here. Now what is my channel width? from here?
Reduce.
Channel width will reduce means the number of carriers which are passing from source to drain, that will also reduce.
Yes, sir. And current flow will low.
Current will less, or
Yes,
drain
sir.
current will reduce. So that current controlled, ID is my output current, which is controlled by what?
Voltage.
Get to source voltage.
Yes, sir.
So that's why this is called as voltage control
Voltage
device,
control.
and the output current can be controlled by get to source voltage. Okay, this is the fundamental idea of JFET. Now the basic thing is the reverse bias junction. If you reverse bias the PN junction, then it is controlling my output current. Can I
Sir,
give
it
forward
will
bias?
be always reverse bias, sir.
That's what I am asking. Can I forward bias? Can I give positive voltage here, VGS? If I give positive voltage here, then what will happen? Can I control the current ID? If the junction is forward biased, what will happen? The PN junction is forward biased, so what I'll get? Can I get the depletion region here? The PN junction forward bias होगा तो depletion region क्या होगा?
बढ़ जाएगा, sir.
बढ़ जाएगा ना घट जाएगा?
Increase.
Increase.
Depletion region decreases, sir.
Depletion region decreases. Okay. So depletion region decreases means after certain voltage, there will be no depletion region.
Yes, sir.
Okay. So there will be no depletion region means the holes which are present here can easily move to this side. This side, electron can easily move to this side, right?
Yes,
So
sir.
can I control this current?
No, sir.
Control this current. The carriers which are moving from here, can I increase or decrease depend upon this voltage? Channel will be from here to here, all are channel. This is like the electrons will move. So can I control this current by this voltage?
I think so. No, sir.
Obviously no, because there is no controlling parameter in reverse bias, because the channel is decreasing or increasing. That's why the current can be controlled. But here already the junction is forward bias means the junction is open. So here there is no controlling parameter by which we can control the output current. So that's why we can only give reverse bias here so that we can control the current. If we apply less reverse bias, then more current. More reverse bias means less current. Okay. Now
Yes, sir.
this is the logic. Now let us go for the operation with different voltages. Okay. So let us first take okay. So let us first, I'll sort it. Means reverse bias means what is the minimum voltage? Negative का minimum कितना है? What is the minimum value of negative?
Sir, -2.
हाँ, -2 से और मिनिमम वैल्यू नहीं है?
0.7.
तुम दिमाग मत लगाओ, बिना दिमाग लगा के बताओ। नेगेटिव का सबसे मिनिमम क्या है?
Sir, माइनस इन्फिनिटी।
अरे नेगेटिव का सबसे कम वैल्यू कितना है? 0 ना?
जीरो जीरो यस सर।
0 is the minimum value.
Yes, sir.
Then we can increase -1, -2, -3 जितना भी नेगेटिव कर सकते हो. So if you move from negative to positive, then the minimum value is 0. So I'll first take VGS equals to 0 volt. Then I'll connect VDS. This is your VDS. Okay. Now suppose this is open. VDS is open circuited. That means VDS 0, VGS 0. What is my ID? Tell me. Voltage, input voltage 0, output voltage 0. Can the electrons will move from source to drain? If I'll not apply any voltage?
No, sir.
No. So ID also 0. Now what I'll do, I'll connect voltage here and I'll start increasing its 0 to 0.1, 0.2, 0.3 like that. So I'm giving positive voltage means the electrons which are moving randomly inside the channel or material, they will be drifting towards the drain due to this positive potential, so that I'll get ID. Yes or no? If I try to draw the characteristic here, output voltage VDS versus output current ID. So when VDS 0, I'm getting 0 current. Now when I increase the VDS from 0 to higher voltage, then current is increases linearly. Am I clear?
Yes, sir.
If we increase more and more voltage, then more and more carriers will transform from source to drain, so current will increase linearly. Now simultaneously what happens, suppose let us assume I am giving here 5 volt. Now I have connected 5 volt here. That means the potential difference between this and this is 5 volt. Yes or no? This is plus, this is minus, so I can say this is 5, this is 0. So the potential difference is 5 volt. Yes or no? हाँ कि नहीं? एक बैटरी में अगर ऐसा है,
Yes, sir.
तो 5 volt में this is 5, this is 0, so potential difference between these 2 points is 5 volt. So same thing is here. So 5 is connected here and 0 is connected here. That means the potential difference between these 2 points is 5 volt. Okay.
Yes, sir.
Now let us see. What I have understood, the potential difference between initial point and end point is 5 volt. Now as current is increases linearly and uniformly doped, I can take this is as uniform resistor like this. I'll divide, and this is my 0 volt from here to here, 1 volt drop from here to here, 2 volt drop from here to here, 3 volt, then here to here 4 volt, then top to bottom 5 volt drop. I can assume like that or not? तो पोटेंशियल ड्रॉप तो हो रहा है बॉटम टू टॉप, ये तो एक साथ नहीं होगा ना. If I divide the entire thing partly, so from here to here it is 1 volt drop, here to here 2 volt drop, here to here 3 volt drop, here to here 4 volt drop, then end to end is 5 volt drop. That means the potential difference between these 2 points is 5 volt. Understood?
Yes, sir.
Now, at this condition, what is my junction voltage? See the PN junction which is reverse biased. See, just a minute. So this is your 1 volt, here 2 volt, 3 volt, 4 volt, 5 volt. Now P is connected to 0 volt and N is connected to, like suppose this is connected here, this is connected here, this is connected here, this is connected here, this is connected here. That means it is connected to 5 volt, here it is connected to 4 volt, 3 volt, 2 volt, 0 volt. Now tell me, from this point to this point, which side will be more reverse biased, which side will be less reverse biased, or uniformly, the entire area is uniformly reverse biased. You can understand like this. This is p-type material and this is n-type material. Okay. So here I'll connect 0 volt, 0 volt, 0 volt, 0 volt, 0 volt. This side I'm connecting 5 volt, here 4 volt, 3 volt, 2 volt, 1 volt, 0 volt. Okay. Now this side will be more reverse biased, this side will be less reverse biased, and in between that it is decreases, or entire thing is uniformly reverse biased. Still not getting? PN junction is reverse biased, less reverse biased and more reverse biased. How will know? Let us see here. This is my PN junction diode. If I want to draw the same picture here, this is my 0 volt. Top side it is connected to 5 volt. This is 0 volt. It is connected to 4 volt. 0 volt, it is connected to 3 volt. 0 volt, it is connected to 2 volt. 0 volt, 1 volt, then 0 volt, 0 volt. Now all the diodes are same type of biased or more reverse biased, less reverse biased? A response. Whether the diodes are reverse bias or forward bias, first tell me. Are you able to hear or not?
Yes, sir.
Then respond. I have drawn here
Reverse.
5 diodes
Reverse bias, sir.
reverse biased. So this one, how much reverse bias? This one will also same reverse biased or more reverse biased or less reverse biased compared to first one.
Which one?
First one
Same,
to
sir.
second one. First one to second one.
So less reverse.
लेस रिवर्स बायस्ड, उसके नीचे जो है वो 3 वोल्ट इफ आई कनेक्ट
So less.
लेस,
More less.
दिस वन इफ आई कनेक्ट 2 वोल्ट
So less.
still less from 3 volt. If I connect 1 volt, it is still less than 2 volt.
Yes, sir.
Yes, sir.
Now in which case the depletion region will be more wider?
5 volts, sir.
5 volt. So as the reverse bias decreases, the depletion region also decreases. So here what happens, from that logic, the top side will be more reverse biased and bottom side will be less reverse biased. So the depletion region will be like this, weight shape. You can see here more depletion width, here less depletion width. Similarly, this side also more depletion width, this side will be less depletion width. Okay. Now if I increase 5 volt to 6 volt, 7 volt, 8 volt, then what will happen? The depletion region will increase and at some point of time they will touch each other. Suppose at 7 volt they will touch each other. These depletion region are touching each other. Then can I get any current, drain current, or the channel is existing or not at this 7 volt? The channel is present or not? Can the electrons will move from source to drain in this condition? If depletion region is like this, can the electron will move from source to drain? Is there any path existing or not from source to drain? ये तुम्हें दिखाई नहीं दे रहा है? Electrons are present here and they try to move this direction. Can they pass from source to drain if the depletion region is touching each other from both sides?
No, sir.
Then current will 0.
Yes, sir.
So let us assume at this point I have given some voltage so that the channel is blocked. That voltage is called as pinch off voltage. The voltage at which channel blocks is called as pinch off voltage. But this is the theoretical assumption, but practically it has seen that even if I'll apply this voltage, the depletion region are touching, but a very narrow channel is existing here. So how much current I have got, that current is instead of decreasing, instead of increasing, it will remain same. So this is the constant current I'll get once I apply this pinch of voltage. And this current is known as IDSS, drain saturation current at VGS 0 volt. Whatever assumption I have taken, I have started with VGS 0. So at VGS 0, whatever current I am getting, that is called as drain saturation current. And the voltage at which it saturates is called as pinch of voltage, in which the channel blocks. Okay. Now, if everything will remain same, instead of 0, I'll connect here -1 volt. Then current will decrease or increase. Or you tell me, when I connect VGS 0 volt, in that case the depletion will be wider. Or when I connect -1 volt, in that case the depletion region will be wider.
सर समझ में नहीं आया सर ये.
Suppose this is the 0 volt. When I have taken 0 volt, what I have taken? This is my depletion region.
Yes sir.
Now I change this 0 volt to -1 volt. Instead of here, I'll connect one -1 volt. Now in this case, I'll get more depletion region or less depletion region compared to 0 volt when I have connected.
Sir less saturation.
Less saturation. Saturation को बाद में आएंगे. पहले बोलो depletion region will be more or less?
Less sir.
Depletion region less. The junction is more reverse bias or less reverse bias if I connect -1. Suppose instead of this 0, you see this diode structure. I am connecting -1, -1. Then the junction will be more reverse biased or less reverse biased? When I have connected 0 and 5 volt and I have changed to -1 to 5 volt, then it will be less reverse biased or means more reverse biased? Zero, 5 volt, -1 volt, 5 volt. Which will be more reverse biased, which will be less reverse biased? Here -1 is connected, here 0 is connected. So more negative, less negative, this will be more reverse biased and this will be less reverse biased or not?
Yes sir.
Now same concept if you apply, then -1 means it will be more reverse bias compared to when 0 is connected. So if you compare this one, the channel width is this much earlier. Now the channel width is decreases. Now channel width decreases means how much current is flowing. Now less current will flow.
Yes sir.
Everything, all the characteristic, whatever we have discussed, that is shifted downward if I connect here VGS -1 volt. Okay. So let us see here. See this one. This is the original structure. Now if I connect when VGS 0, I have explained this one. When VGS 0, this portion will touch each other, so ID will decrease. Now, at this point, that is VGS equals to VP, the channel pinch off. Okay, this is given as pinch off, so channel blocks, so current will reduce to 0. but practically it has seen that it is not reducing after this point. Okay, current will saturate from here. So for VGS 0, this is the saturation level, and this is your IDSS. Okay, what I have explained now. Now, if I give negative voltage, then compared to 0, here channel is less, so I'll get less current. You see, 0 volt I'm getting for -1, it is reducing. For -2 still reduce, -3 still reduce, -4 this one. When I apply VGS equals to -5, okay, then current will be 0, because even if I am applying VDS positive voltage, I'll not find any channel, and that voltage is VGS off. Okay, so if there is no channel, then obviously the current will be 0. The carriers will not move from source to drain. Okay, now this is for N channel. Just opposite, if I apply, sorry, this is the same thing. N channel means this is for negative voltage, current is reducing. For VGS I am getting maximum current. Now if you take positive voltage, P channel, then opposite thing. That means whenever we are giving positive voltage, current will be controlled. Okay, and here the P type substrate you have to take, gate will be N type, and here you have to connect negative voltage so that holes will be attracted from source to drain. And VGS will be positive, then current will reduce, and for 0 it is giving you maximum current. This is the equation which is called a Shockley's equation. So ID, that means drain current at any point, is equals to IDSS 1 minus VGS by VP whole square. Okay, so you can see here the output current is ID, is controlled by the input voltage VGS. So that's why it is called as voltage controlled device. When VGS 0 means 0 by something is 0, 1 minus 0, 0, sorry, 1 minus 0, 1, 1 into IDSS, that is ID equals to IDSS. Now if VGS equals to VP, that is equals to VGS off, then it will give you 1, 1 minus 1, 0, 0 into something, that is 0, so ID equals to 0, what we have just now seen. See, for VGS 0 volt, I am getting IDSS. Okay, and for VGS equals to VGS off, this current will be 0. Okay, so you remember this equation. This is coming in the exam. Any one parameter will be asked. So this is your output characteristic we have discussed. Now if I want to find the transfer characteristic means input voltage versus output current. Just you need to extend these points. Okay, so x-axis you take input voltage, that is VGS. So when VGS 0, what I am getting? Maximum current, that is IDSS. Yeah. When VGS minus 1, how much current I am getting? VGS minus 1, I am getting less current compared to IDSS. Similarly, for minus 2, you just extend this one, I am getting less current here. For minus 3, I am getting still less current here. Then for VGS minus 4, how much current I am getting? 0. So at minus 4, I am getting 0 current. So if you join all these points, it will be exponential decreasing function. And this is called as transfer characteristic of the N-channel JFET. Okay, so this is called as N-channel transfer characteristic, and this is your output characteristic of JFET. Okay, so if you same way, if you try to plot for P channel, then instead of this negative, it will be plus, and instead of this negative, this will be plus. So graph will be like this, exponential decaying function, but it is 0 to positive value. Okay, I think I have mentioned here. Okay, I have not mentioned. So you can draw P type JFET. So this is all about your junction field effect transistor. So you may get a question like define or explain the operation of N channel JFET or P channel JFET. So you have to explain like this by connecting VGS 0 volt, then characteristic, then VGS minus 1, how it is decreasing. Okay, how it is decreasing. Then you may also get draw the structure of JFET as well as output characteristic and transfer characteristic. You can also draw it. Okay. Then you may get a question like related to this equation, what is supply equation, and explain each parameter, as well as you have to find the one of the parameter from here. Then for P channel it will be same. So this is all about today's lecture. Next class tomorrow we'll discuss MOSFET, and Friday we'll take a test. Okay, I think tomorrow is a holiday.
Yeah, sir. Tomorrow holiday.
Tomorrow holiday means Wednesday we'll go for MOSFET, and if possible we'll take test. Otherwise next Monday we'll take the test. Weekly test from transistor characteristic to JFET.
Okay, sir.
Sir, can we have the test on Monday because we already have a scheduled test of physics on
Wednesday.
Friday.
No, Friday I have class on Wednesday, right? So let us see. Means if MOSFET will complete, then we'll take. Otherwise, we'll take on Monday.
Okay.
Completed transistor characteristic, because up to transistor characteristic we have done in before mid-sem. So after that, up to JFET we'll discuss. Just a
Sir,
minute.
sir, how many topics more are remaining, sir?
3-4 topics are there.
So PPT भेज दीजिएगा.
PPT, after the class I will upload. You all are not studying properly. You study because you are not responding. It's even very simple PN junction diode, reverse bias, forward bias. If you not tell, then how can we proceed? Huh? Because everything is basics. If you understand the basics, then only you can proceed.
Yes, sir. Sir, in third semester we have continuous of this AEC.
You have DEC, digital electronic circuit. Logic gates and adder, subtractor, all those things are there. Okay, I've taken the attendance. You may leave now.
Thank you, sir.
Thank you, sir.